our Earth's moon, so familiar to us and yet so mysterious. Down here near the bottom, we find what is clearly an impact crater, and probably an historically recent one. Look at this crater's immense splash trails. This splash trail travels across the entire face of the moon, about the distance from Florida to New York. This is so an impact crater. Up here is another easily identifiable impact crater, and here is another. At least we have splash indicators that cause us to believe that this is so. But what on Earth, well, what on the moon is this gigantic spread of flattened, slightly depressed land? We have a name for it. We call it Mare Serenitatis, the Sea of Serenity. According to this theory, this image is the moon about 400 million years ago. The mares exist only in their early primitive stages, much smaller, before Jupiter grew large enough to be our gravitational umbrella. The mares will grow and expand as you watch. The spreads will grow and the moon grows up to this size. This is our present moon. For careful examination and study or scrutiny, we will go backward in time and watch the mares close down. Importantly, 50% of the volume of the moon is now gone. 50%, half. We'll go forward and backward one more time. While we do, remember we are reducing and enlarging only those gigantic spreads or mares. This has led to a significant and interesting problem. If we say these spreads or mares are eruptive growth from the inside of the moon, and we do, wouldn't the gravitational pull of the Earth exerted on the Earth's side of the moon cause most, if not all, of the growth to erupt toward the Earth? In fact, wouldn't that imply that these eruptive mares should not exist on the side of the moon which faces away from the Earth? This is what the common sense logic says, but let's see what reality says. In fact, as you can see, on this very detailed image, the far side of the moon has virtually no gigantic mares or spreads. Well, there's a suspicious candidate, but you can see it's smallish by comparison to the gigantic spreads on the Earth side of the moon. In fact, the tectonic spreads on the Earth side give the Earth side a totally different look than the far side. You remember that eruption on the lower right of the moon's rear? Yes, that one there. Actually, that spread is on the border between both sides. If the mares on the front side spread as we say, that spread was once on the Earth side of the moon. Front side expansion growth drove it to the side. This is a familiar moon photo to some. A mystery. It's a tectonic spread, and we're about to close it. Incredible. Got another mystery. Looks like an alien landing strip, doesn't it? It's not. It's a spread. Here is a gigantic crack, a crevice in our moon. These two sides have spread open, revealing a lower tectonic surface. It's been named Schroeder's Valley. It runs an average of 16 miles wide through its length, which is roughly 600 miles long. If you look inside, you'll see a new spread beginning. The best analogy on Earth is the Grand Canyon. The Grand Canyon, a tectonic spread? Oops, no. It's not carved by rushing water. It's a tectonic spread. It simply happens to be in a convenient place for water to run in. Monument Valley, the Painted Desert, Zion National Park, and nearly all this general area is tectonic spread area. It's easy to identify spread areas in cross-section. They look like this. Normally, these were, in the ages of dinosaurs, warm, shallow seas. Back on the moon, we're closing this very neat crack. I know, too easy, I agree. During earthquakes, we see this earth-spreading thing all the time. You ever ask yourself, if it opened up, where did that land go? Outward from the center, yes, but it didn't compress, it moved. But our moon cracked open 15 miles wide. So did the Valles Marineris on Mars. So did the Grand Canyon. So did this canyon on this moon of Uranus. It's called Ariel. Please look at these tectonic rifts of spreading upper tectonic plate. And here, this is Enceladus, a moon of Jupiter. These two are spreading tectonic surface. Call them stretch marks. This is Europa, a moon of Jupiter. It has a most incredible surface. Speculation as to its surface composition has included ice, slushy ice, and, well, whatever. Doesn't look like ice to me. I don't think ice pushes up ridges like these, but there you go. Whatever it is, the mineral cracks and spreads as Europa grows. This is the latest photo that NASA has supplied to us on the internet. See that gash down the middle? It's a tectonic spread. Actually, NASA seems to think so too, which is, yes, a surprise. Let me show you why a spread is the only proper description for what you see here. First, some small cracks happen more currently than the big spread, so we'll put X's on them to mark them. We know they're newer because they invaded the spread here, 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 and here. The rest of the cracks are older than the spread. I've asked Zia to cut up one side of the spread. Thanks, Z. Now we'll move this side over to the other side and swing the bottom over. Good. All these sides match exactly, so much so that the line that defines the crack disappears. I think anyone can see this clearly. Here's another crack. The land spread up to the right, so let's bring it down and left. There. I believe this is ongoing eruptive silicate growth from the moon's inside. If this isn't growth of this moon, where is this material going? Maybe it's subducting. Kidding. Can you spot the break now? No, it's here. Isn't that incredible? The surface area here has been reduced by 1/4 or more, and it happens all over this moon. When I saw this photo, I bet myself that the area on the lower right-hand side matched its opposite surface on the upper left-hand side. So let's try it. You can do this experiment yourself using the same photos from NASA. This moon, just like all moons, and all planets, and all suns, and our whole universe, is growing. This is Ganymede, a moon of Jupiter. It has a very distinctive surface. The darker areas are older, higher, raised surfaces. How do we know this? First, the darker surfaces have been measured as higher tectonically by the scientific community. Secondly, these darker areas have a greater abundance of meteor hits. More hits equals older surface, as we saw on our moon. I realize this process may seem to be thunderingly obvious to you. It's not to the current scientific community, and they will certainly not buy it easily. So bear with me. As you can see, we are closing the lower tectonic plates to a very dramatic result. Understand, we are only bringing these upper tectonic surfaces together. The result is we have reduced Ganymede by 1/3 of its volume. 1/3, 30%. This just in. When this project began, we had only still photos of Ganymede. Now NASA has a nearly complete map of Ganymede. Some areas are not clear, but for our example, this is terrific. First, we wrap it around a sphere. Good. Now we go back in time and watch as the darker plates move together tectonically. Boy, isn't this a great map NASA's assembled? Look. Let's pick two sides, and yeah, not spin them, and we'll just watch them go back in time. The dark plates don't shrink, just the sphere and the lower tectonic plates. It's like a puzzle. I promise you, I didn't change anything. Well, you can see for yourself. Many moon surfaces don't show this process as well as others, so I'm consciously choosing the easy ones. I leave it for others in the future to continue this work.